to everything I say. When I walk out of the house, they steal my laptop and they install new things on it, and then they put it back. I can't solve that. I'd like to be able to, but one impossible problem at a time. And then also, assume the users can actually get a good copy of Tor. If they go to the Tor website and China gives them a Tor website and China gives them a new program called Tor, or maybe it's China Tor or whatever they're going to call it, I can't solve that one either. But maybe PGP signatures and stuff like that will be a good start. Okay, so what does Tor offer now? What do we have that we're working with? Tor has 3 big anonymity properties. The first one is somebody watching you locally can't figure out what websites you're going to, and they can't decide whether you're allowed to do that. This is clearly useful for blocking resistance. The second one is no single server in the Tor network can figure out both you and where you're going. So they're not able to say, hey, the person over there who works at this factory in China, they've been going to this website. And that means that they probably won't try to just sign up a lot of Tor servers to figure it out. We can talk more about that attack also. And then the third one is the destination can't figure out where you're coming from. You'll notice when you go to Google in various countries, it gives you different languages and even different results. Imagine if China went to Google and said, hey, can you guys not give certain answers? Can you do the censoring for us when somebody's coming from China? I think they do that already to some extent. If people are going through Tor, then Google has no idea what country they're coming from. It can't treat them specially. It can't say, you're coming from China, you can't have this page. So these are the 3 big properties that we get so far with Tor. Another big piece, we have what are called directory authorities. We know how to do simple network discovery. There's a big list of all the Tor servers. It's signed by 5 central servers, and the keys for those central servers come with the source code, come with Tor. So you can go anywhere, you can get a directory, and you say, oh good, I'm using the real Tor network. I'm using the same Tor network that everybody else is using. And this information is cached all around the network, so it's a trust bottleneck. There are only 5 directory authorities, but it's not an actual bandwidth bottleneck. So far, so good? Okay. The second one, the list of directory authorities isn't hardwired. Yes, we come with 5 defaults, but you can turn those off and use your own. You could set up your own Tor network. Some guy in China could say, I'm going to build a China Tor network with these directory authorities inside China. Another assumption that I didn't bring up there that doesn't matter too much yet is they actually just monitor the firewall, the outside connections. There are a lot of people who talk to each other inside China, and they don't go through the same filters, the same firewalls. So yes, you could set up your own Tor network. You probably shouldn't, because splitting up the users is bad for anonymity. But we'll talk about that more later on. Another big key feature of Tor is that we automatically take care of building paths for you. You give us a set of servers, and we'll build some paths, and we'll do all of that in the background. So in a sense, Tor is just a tool that you give it some servers, and it builds the anonymous paths and takes care of all that for you. There's a project at Harvard called Blossom, where he has a separate Tor network, a separate set of directories, and the goal there is not anonymity, it's reachability. He wants to say, what does Google look like from Thailand? What does my website look like from Iceland? Statements like that. So Tor is just an overlay network, and you can do all sorts of things with it, and that will come in handy later on. So another big feature, Tor has a bunch of different roles for the servers. You can be an exit node, meaning I'm going to connect to websites and let people do whatever through me, or you can just be an internal relay. I don't want to let people connect out, but I do want to pass traffic back and forth for Tor users. So the fact that you can sign up to be a relay without signing up to connect to arbitrary servers is really good for us. It means we have a lot more volunteers than we would have otherwise. Something like a third or half of the Tor servers right now are exit nodes. So we've got 400 people who aren't willing to be exit nodes, but they're happy to help out. And that's how we end up with more servers than a lot of other systems out there. The increased diversity that we have is what gives Tor its security. The more different choices you have for connecting to the Tor network from all these different servers, or from the Tor network from all these different servers, that's where our security comes from. And then another nice feature, we're still around and we're growing, which is different from pretty much every other anonymity system out there. So we have a community of people who help out. A lot of commercial systems in the past, either they fell apart because they didn't grow, or they constantly need to collect money from their users so they can continue to pay for their bandwidth. We rely on nice volunteers who have extra bandwidth, and we just coordinate them all into one Tor network. So we don't have to own it, we don't have to control it. You can do whatever you want to with it. And the sustainability for Tor is based on the open design. We tell you exactly how it works. It's modular. You can build all sorts of things with it. It's free software. And we got a whole lot of users. Another nice feature we can build on is there are a few 100,000 people out there who are using it, and they're a very diverse group. Ordinary citizens, activists, corporations, law enforcement, governments, you name it. And that's why we are so sustainable, because there are all these different groups who say, you can't take anonymity away, I'm using it. You can't take my network security away, I'm using it. You can't take my traffic analysis resistance away, I'm using it. So hopefully that will be very helpful to us down the road. And also, there are a lot of different IP addresses that it provides. So another couple of points to make. A lot of people working on censorship resistance say, we don't need anonymity, we're working on censorship resistance. Let me give you a few examples for why it might matter. Imagine a Chinese worker at some factory, and she wants to blog about something that just happened at her factory. The approach that a lot of censorship-resistant systems use is she gets her uncle in Ohio to run a relay for her, and she uses that to blog about what just happened at her factory. Imagine that the Chinese authorities figure out who posted the blog, and they say, hey, wait a minute, this person is related to the person who works at the factory. That's probably not a good thing. Another issue we might worry about, if any of the Tor relays, if any of the relays that you're using can figure out both who you are and where you're going to, then the bad guys should just sign up those relays, and they should start making big lists of this person did this, and this person did this, and this person did this. So we really need an anonymity system in the middle. They don't actually have to sign anything up, they can just tell you that they did. They can just say, oh yeah, that one's easy, we're half the network. We'll watch everything you do. Okay, so that's what Tor has right now, and hopefully that'll give you a bit of background on what Tor does. There are a bunch of different systems out there that are similar to what we're trying to build, and we're going to try to make use of them in the design I'm going to talk about. Okay, so the big picture, how do you build a circumvention system? How do you build a proxying scheme? There are two big pieces to them. The first piece is the relay component. How do you actually build the paths? How do you actually send the traffic back and forth, do the encryption, stuff like that? The second piece is discovery. How do you figure out what the servers are? In the case of Tor, the relay component is the complex part, and the discovery part we just added at the end. We just said, okay, there's a big directory and it has all the servers and you get it and then you know. But there are a lot of other ways that we could do it. So the easy example here of how a lot of the proxying systems work right now are systems like anonymizer.com. It's the big computer, it lives somewhere in San Diego, all the users go to it and then go somewhere. So the idea is it's one organization that controls the proxies centrally, and also you aggregate all the users onto that proxy and then go from there. We can talk about the security of that compared to Tor. Hopefully the picture at the beginning gave you a good sense of that. The big issue there is the adversary, if he wants to block it, can just block that big computer in San Diego. So they end up hopping and buying a lot of new IP addresses and using those for a little while and so on. We'll talk about how that works in a bit also. So the opposite end of the spectrum is independent personal proxies, where I get a computer and I set it up just for my cousin in China, and then I tell my cousin in China, here's the address, you should use it, don't tell anybody else. And that's great for blocking resistance. Nobody in China is ever going to notice that that thing exists because it has one user, and one user in a country of 1 billion people. Doesn't matter at all. On the other hand, there's a huge scalability question. How does the guy in China find the guy in Ohio if they don't already have a relative there? And how does the nice guy in Ohio who says, I want to help out, find the guy in China? So yes, this is a great idea, but how do you actually get it to matter for more than 12 people? And then there are open proxies. Go to Google and search for open proxy list, and you'll find lists of tens of thousands, hundreds of thousands of misconfigured or Trojaned or intentionally open systems, and you can do whatever you like to with them. Sometimes they're SOX proxies, sometimes HTTP. So there are a lot of different questions here. Sometimes they aren't very stable, aren't very fast. There are actually companies in Russia that go through them all and figure out which ones are good. And if you pay $10 a month or something like that, then you can get a better list of open proxies. So there's a whole industry on how to find open proxies. On the other hand, most of them are not encrypted, which means that the filtering I talked about before could still work. They still see what you do. And then on the third hand, a lot of people say, are these too convenient? Who set this up, and who's looking at it, and why should I use this? On the other hand, they're great for maybe bootstrapping, maybe a few connections you can do at once. The Java and non-proxy folks have a design that's kind of similar to the one that I'm going to talk about today. They wrote a paper a few years ago, and I haven't heard from them since about what they're up to. Hopefully they've learned a little bit too. The idea that they have is they use YAP rather than Tor. We can talk about the anonymity properties between them later on also. And the way they do discovery, you go to a central website, you solve a CAPTCHA, a little thing that says, tell me what these letters are, and then it gives you some address that you can use to get to the YAP network. And then internal caching networks. I hear from a lot of people that there is a Freenet network running inside China. Yes, you can't cross the firewall very well, but there are a lot of people inside, and somebody goes and fetches the front page for CNN and puts it into the Freenet on the inside, and then a lot of people inside China can get to it. Apparently there was a talk here last year on how to build a darknet version of China, of Freenet. Maybe we can make use of that in some way. There are definitely usability issues with the current Freenet implementation, and there are maybe anonymity issues with the current Freenet design, depending on what it actually is, if they would ever write it down. And then there's Skype, which might be useful in some way. It's got port switching and encryption and lots of other features like that. It still has a central login server, so it's not going to totally solve our problem, but it might also be a nice tool to build on. And then there's Tor itself. There are 30,000 people, give or take, in China using Tor right now. And they don't mind the anonymity properties, but they're using it so they can actually get to the websites they want to talk to. Tor's website is blocked all over. It's blocked in Egypt and various Arab groups in China and Thailand and the LA Times. A lot of different places block the Tor website. But nobody that I've heard of blocks the Tor network. Why is this? One answer is tens of thousands of users, who cares? That's nothing. Nobody's using it. Another answer is that we've publicized it as Tor is for experts. Tor is for people who know what they're doing. One easy way of doing that is to distribute it in only English and Deutsch and Russian and things like that. We don't have a Chinese version that's very useful yet. So maybe that helps a lot. Another answer is that we've always been talking about it as Tor is for civil liberties. Tor is for people in North America and Europe who really need to have security against their corporations and their governments and things like that. We've never been talking about it as Tor is for human rights people who don't have very good internet connections. So maybe that means that they don't think of it as a threat. Nobody has gone to the governor or the president or whatever the name is in China and said, hey, why are you not blocking Tor? These guys are going to destroy our civilization. But I guess the key point here is that we should realize we're already in the arms race. There are already tens of thousands of users in China using it, and they haven't stopped them. So yes, we're up against a very powerful adversary, but it's not... the adversary is not trying to crack down every single time, every single opportunity. They're taking the correct opportunities, they're taking their time, maybe they're slow, maybe they don't mind so much. Okay, so what do we need to add to Tor so that we can actually have these sort of systems? One easy answer is we got a lot of users. We've got hundreds of thousands of people out there who are using Tor. What if we give them a little button in the GUI that says Tor for freedom? And the user clicks the button, and now they turn into a little relay. They relay